isolate the variable. I always like to start with building a fence where the equal sign is so that both sides of the equation stay balanced. I want to always isolate the variable, that means get it by itself, so I want to get y by itself, so I think of what's attached to it. Well, there's two terms, and I want to get rid of this term, get rid of the negative 15. So the inverse of negative 15, or subtract 15, is plus 15. And if I have negative 15 and plus 15, that makes 0, and I'm left with 1y, or just y. Now, if I add 15 on one side, I need to make sure I add 15 on the other side, so that it stays balanced. So what's negative 4 plus 15? Well, that's going to equal a positive 11. And then I like to check. So I plug it back into the original problem. So y minus 15 equals negative 4. So the y is 11. Subtract 15, and does that equal negative 4? Well, what's 11 minus 15? That is negative 4, so negative 4 does equal negative 4. Check. All right, problem number 2. Again, start with building a fence. My goal is to get the variable by itself. Attached to it is the term negative 7. What's the inverse of negative 7? Plus 7, or positive 7. So I'm going to put plus 7 on both sides of the equation. That keeps it balanced. If I have negative 7 and plus 7, that makes 0. I am left with positive x. And what's negative 3 plus 7? Positive 4.
And now I want to double check that my answer is correct, so I'm going to plug that into this original problem, which was negative 7 plus whatever x is. Does that equal negative 3? And the variable is 4. So what's negative 7 plus 4? It is in fact negative 3, so it is true. Excellent.
Number 3. Once again, start with building my fence. This time the variable is on the right side of the equation. I have minus a negative 15, or the opposite of negative 15. Well, what's the opposite of negative 15? This is a big old plus, right? Two negatives, a negative times a negative, this is a positive. So if I want to get rid of that plus 15 or that positive 15, the inverse operation is minus 15. If I subtract 15 on this side, I must subtract 15 on this side. All right, negative 11 minus 15 makes negative 26. And does in fact a positive 15 and a negative 15 make 0? Yes, so I'm left with 1z. Do you need to have the variable on the left? No. Negative 26 equals z is the same as z equals negative 26. All right, look at my original problem. Plug it in. So my original problem was negative 11 equals z, which is negative 26, minus a negative 15. Okay? Well, remember, minus a negative 15 is actually plus a 15. So what is negative 26 and positive 15? That makes a negative and 11. Oh, good. That's what I had on the other side of the equation, so check yours. Hey, looks like a happy face. All right, number 4, build your fence. C is on the right side. Get rid of what's attached to it, which is negative 35. What's the inverse of negative 35? Plus 35. So 25 and 35 makes 60, and negative 35 and positive 35 make 0, but what do I have left? Uh-oh, this one's tricky. I don't have just a c left. I have a negative c left. Or you could say the opposite of c left. Well, I need an extra step in this problem, so it's not really a one operation problem. You have two ways of getting rid of that negative or that opposite. Well, what's the opposite of negative c? You can think of what's the opposite of both sides. So what's the opposite of negative c? C, 60. The opposite is negative 60. So you can think of taking the opposites of both sides. That would be doing the same thing to both sides of the equation. Or if that seems uncomfortable, you could basically multiply this whole equation by negative 1. Doing, again, the same thing to both sides of the equation. This times negative 1 makes positive. This times a negative 1 makes a negative. So I end up with c equals negative 60. Plug it into the equation, check and see if it's right. 25 equals negative 35 minus whatever c is. And c is a negative 60. All right, I have a double negative, which makes it a positive. What is negative 35 plus 60? It does, in fact, equal 25, which is what I had over here. Yay!
Ladies and gentlemen, welcome to New Orleans.
So again, I'm going to build my fence. My variable is on the right. What's attached to it? A negative 2. How is the negative 2 attached to it? By division. So what's the inverse of division? Multiplication. Now, how I like us to show the multiplication, so you can see it actually canceling out, is multiply this by negative 2. Now, I want to write it as a fraction so I can see it cross-simplify. So what is negative 2 as a fraction? Well, it's negative 2 over 1. So I'm going to multiply by negative 2 over 1. What I see happen is the negative 2 cancels because, or simplifies to a positive 1. So what I'm really left with on the right is just an h. And on the left, I have negative 2 over 1 times 36, so that equals a negative 72.
Multiply both sides by negative 3 over 2. So, what I see happens is this will multiply, and in fact, these will all cancel out. This will make 1, a positive 1, because negative times negative is positive, so I'm left with just a w. And over here I'm going to make negative 70 over 1. I can multiply first and simplify after, or I also see that 2 goes into 2 once, and 2 goes into negative 70, negative 35 times. So now if I multiply, I will get my solution. A negative times a negative is a positive. 35 times 3, how I like to do it is 30 times 3 is 90, and 5 times 3 is 15. So 90 and 15 is 105. And we already said positive. Great. Plug it in to see if it's true. Negative 2/3 times 105 is supposed to equal negative 70. Well, I can already look at it. I've got negative times a positive equals negative, so that's good. Otherwise, I want to simplify, or if you'd rather, we could multiply and simplify after, which would be negative 210 divided by 3. Geez, let's see. Yeah, 3 goes into 21 7 times, and so then we'd have a 0, so this does, in fact, equal negative 70. Great. Number 7, build your fence 6 times m. I want to get m by itself. How is 6 attached? Be multiplication. And what's the inverse of multiplication? Division. So instead, I could multiply by 1 over 6, the reciprocal, but I'm going to just divide by 6. Now, how do we show division? Fractions. So what I see is I have 6 divided by 6, which is 1. So I am left with 1m. And what's negative 72 divided by 6? Negative 12. Now, I want to check, so plugged into the original problem, 6 times m, which is negative 12. The question is, does this in fact equals negative 72? And yes, it does. Negative 72 does equal negative 72. Yay! All right, number 8. This is a proportion, if you want to think of it that way. Or you can just say it's y being divided by 4 is equal to 15/6. My goal is to get y by itself. So y is being divided by 4, so the inverse of divide by 4 is multiply by 4. Again, when I'm showing that multiply by 4, I like to make it a fraction, so I'm going to put it 4 over 1. If I do it to one side, I must do it to the other side. The 4's simplify out to a 1. I'm left with y. And let's see, can I simplify anything over here? Yeah, 4 goes into 4. Well, wait, 4 doesn't go into 6. What goes into 4 and 6? 2. 2 goes into 4 twice, and 2 goes into 6 3 times. So I could multiply this out. I'd have 15 times 2 is 30. My denominator is a 3. Well, wait a minute. What's 30 over 3? 10. So y equals 10. Now, check. Plug it into the original problem. 10 over 4, does that equal 15 over 6?
Well, I see 2 fractions that I can simplify. So if I simplify this fraction down, I could also do long division or change it into a mixed number. Any of these methods work. I'm just going to simplify. 2 goes into 4 twice, and 2 goes into 10 5 times. So this simplifies to 5 over 2. And 3 goes in both of these. 3 goes into 6 twice, and 3 goes into 15 5 times. And they both do simplify to 5 over 2. So I checked it and I got it right. Yeah!